Well, guys, I'm going to have a bit of a go at a microwave transformer. Now, this is a bit of a story to it. My wife wants to do a little bit of garden art and needs a spot welder. So, as we've seen, these are the things to use apparently. I haven't done this one before. Let's have a crack at it. So, what I've done, hacksaw straight down here, and so far that's where we've got to. Sorry about the camera work, she's a quickie, this one. So we've just got to knock those out. And there should be, this is a fairly big transformer. It's out of a Sharp microwave, late 70s. So she's got a bit of oomph in her. So yeah, we'll knock these out. And yeah, there's our windings. It's what she all looks like after you would have seen these 100 times on YouTube. So, and we've got our tappings around the side, and we've even got a little 18 volt winding there which I can use for the electronics, which is this one. Don't need much current, but handy having an 18 volt winding there for the electronics of this. I've got a little board that measures the time and the current that this transformer's on. So, okay, that's where we're starting. Be interesting to see where this ends up. Okay, guys, catch you on the next one. Well, guys, here's the transformer. And just before I go ahead with this, I'm just amazed at the amount of people that build these spot welders on YouTube, and there's no talking. No one tells you what to do, what they're using. Yeah, it just, it just makes it hard for anyone that just wants to know, well, how big is the wire that we've got to put in here, and what sort of transformer have we got to use? What's the best way of controlling it as far as timing and all this? No, there's none of that, which yeah, is a little bit disappointing because there's some good videos on there. But anyway, the winding on this one we won't be using, so I'll be blanking him off. The only windings we're using, being in Australia, is the 240 volt windings. So we've got neutral and active across those two. I have put some insulation over those fellas, just a bit of heat shrink to just tidy it up, keep them out of the road. I've knocked the centre out, and as you can see, I've sawn down there. Now, what we've got to do, actually, I'll just grab the centre and show you what it is. Okay, well, here it is. Now, this was the high voltage winding that was in the top of this fella. So I've knocked him out, as you've seen by on another 100 videos, after we cut off the end. Okay, so we've just cut him off with just a hacksaw and just put a punch in here and a hammer and punched him out. So we don't need this. Now, this transformer is a fair size transformer. It's out of a very old microwave, but it's very high current, it was for early magnetrons, rated in around the 1200 watts, the 11 to 1200 watts of power to run the magnetron. They were earlier magnetrons than, of course, than what we've got now. Well, they weren't quite as efficient as what we've got. Now, I've got the biggest transformer that I could possibly find in an old microwave. Okay, it was an old Sharp. So, this is what we've got. Please take note of that. Okay, now, yes, we haven't got the discharge cap and everything else, but we are dealing with 240 volts on there. So when you're doing this, do it. If you're confident, do it. Otherwise, get someone else to wire this thing up for you. That part there is the lethal bit. Okay, our winding up the top, it's only 3 volts. It's not going to hurt us. But just when we do these, put some covering on them. In actual fact, it'd be nice to put a cover over the whole bit, which I probably will do, so that you can't accidentally touch the AC voltage there. All right, so I'm raving on about it, but please be very careful. That can grab you. It's 240 volts. After we knock the top out of here, you're left with 2 small iron cores well, not cores, they're plates on each side. And then under there, we have the old filament winding of the transformer that goes to power the filament in the magnetron. Knock these out. They are there to reduce the current induced into the top of the high voltage winding, so we don't get too much current out of there, more or less. So both of these have to be knocked out, and that enables you to just get rid of the little bits of remnants of the old filament winding. So let's do that. I'll show you about that. I'll show you that as we go along. Now, I had no cable to go here, so what better place that we go to is our local recycle shop, and I found a set of old jumper leads, fairly heavy jumper leads. That's some pretty serious cable. Size wise, well, it's a pretty hefty cable. So let's have a look. Not many people tell you what cable they're using. Now, I just picked this up at the recycle centre. It cost me $1. The 2 clamps on the other end were both burnt and non-existent, but the wire was quite okay. Overall, we're looking close to 12 mil there. Okay, 11.25. And the cable itself, fairly thin on the insulation. Cable itself be 10 mil. I reckon that's close to 10 mil there. Maybe 9 mil if we squeeze it a little bit. No, in around 10 mil of the cross section of the cable itself. So in around size, what is it, 0 or 1? AWG size cable size. I'm not real sure of cable sizes, but this will do the job amples. I've got a 1.2 metre. No, I haven't. I've got a 1.8 metre piece here. Amples to do the job. I'll be bringing the leads out in around 30 centimetres long, and they'll be bolted to a copper strip that goes to the head of the machine. How I'm going to do that yet, don't know. This is a work in progress, so I just tell you as I go along. Okay, so next up, we'll knock these out and we'll wind this in and give her a test and see how much current we can get out of this thing. Okay, the next step, I have it connected via a dim bulb at the moment, which you can see over there. Now, just a moment, we have a phone call. Sorry about that, guys. I get quite a few phone calls during the day here. So, I've got it through the dim bulb. We're exactly on 240 volts, and we're drawing 67 watts to run this tranny. Now, I was looking for about 3 volts. Let's take it off dim bulb and see, can I get close to that? And that's pretty close, 2.96. I reckon that's pretty close to 3 volts. So it's 1 volt per winding. And if you're doing this, remember, this 240 sits there on the primary of the transformer. Please be careful. If you're not sure, get someone else to do it. And if you're reasonably like me and take precautions, put it through a dim bulb in case there's anything wrong with the transformer to start with, in case it's shorted, it's been in the rain or something's wrong with it. Put it through a dim bulb if you've got one of those. Okay, so the secondary, 2.96. I'm very happy with that. So let's get this thing going on a bit of a load, and we'll put I don't know, a nail or something across it and see what happens. See what goes bang. Here it is, temporarily connected up. I've got what was the old 3-inch nail. I don't know, what are they? 80 mil, 75 mil. And just got him clamped in there. And let's see, I've got a temporary button here. So we just press it to energise things. Let's see what happens. And ooh, yeah, I think she seems to be cruising okay. Bit of a bang to start with, almost shit myself, but yeah, that's pretty spectacular actually. That's a decent sized load. That's only what would it be, 50 mil long, 60 mil long from point to point, and heats it up no problem at all. And the actual cable is warm to touch. Obviously there's resistance on the ends because we've just got a clamp there. But yeah, this is certainly going to work as a very, very nice spot welder. So all we've got to do is replace this thing here with a little timer board, which I'll show you next. And just before we do that, how about we put a clamp meter on the AC side and see what current our AC is actually drawing. That way we can work out what our transformer's doing. Yeah, I saw 10 amps there. 6. But I did see the nail's got hot now, so she's backed off a little bit. But I did see, I'm pretty sure I saw 10 amps. We'll have to have a look at this video, won't we? To screen capture what it actually was. I'll try it again. 7 amps. I think I saw 10 amps, so that's yeah, 2400 watts going in. So that way we can work out what the 3 volt output is. Right, now what I'm using for the electronics part of this is one of these little Chinese boards. They're available on eBay. This one I think was about 17, 18 Australian dollars. They're not very dear. Chinese written all over it, but Google Translate soon gets you going there as far as knowing what lead does what and so forth. But we'll talk you through that anyway when we're putting this in. So yeah, these little boards, it's not worth building your own. I was going to do an Arduino type setup, but no, these these are just as good. The Triac, it's a BTA 100-1200, so it's rated at 100 amps, supposedly 100 amps at 1200 volts. I wouldn't like to be putting that through it, but in our case, we're limited to we're maximum we're using is in around 11, 12 amps, possibly at a burst. So this will handle it no problems. But the thing I've noticed, this comes like this, no heatsink. Okay, so that's an old PCB board, and the GPU had a heatsink on it. I drilled a couple of holes, tapped them with 3mm bolts, and we'll just screw him on there. Okay, so it's a decent sized heatsink. Now, when this heatsink goes on, it's straight onto the metal part of the Triac. This is insulated from the active points through the Triac, but never trust it. Just in case something goes wrong inside one of these, it's Chinese, you don't know what's going to happen here. So don't connect anything to this. Don't touch it. Just put it on there, mount the board in the two holes they're provided on a couple of standoffs, and I'm going to remount the pots and the LEDs to the front panel. So yeah, just take precaution with that. Even though it is insulated and it shouldn't short, you don't know that things can go wrong. And if it goes wrong, well, that's live, active. So at 240. Putting a couple of star washers and a couple of screws so nothing comes undone. Now, what I'm thinking about doing with this, there's your readout, by the way. What I'm thinking about doing is actually mounting this unit and its associated transformer in its own box. The transformer, the microwave transformer, in a separate box. I don't want everything all together. Out of this, we can come straight out of here to say a 3-pin socket, and we can put a cord on the transformer box that just plugs into the side of this. And that way, yes, you can plug it straight into mains. It just means you can then use the transformer as a constant supply, not timed. So yeah, I wouldn't recommend that. I'd recommend pulsing, but supposing you want to, I don't know, heat something, use it as some inductor supply for heating or something. I'm just going to do it separate rather than put all this in one bigger box. This is quite easy to put in a small convenient box, and it just has power in, socket out, and be a nice little display on the front of it, so we can use a fairly small box and a bigger metal box for the transformer. Okay, so that's where we're up to. Let's get on with the next part of this. And by the way, just as a note, I'm using thermal compound, heatsink compound for thermal paste. I highly recommend putting some paste on, or a silicon rubber on these, so there's good heat transfer on the whole thing. Okay, so I normally spread it on, not not thick, but make sure it's all covered like so. And now I will clean my finger up if I can find a rag. There we go. And now we'll put this fella on. Always pays to get things ready before you go to do things, doesn't it? Anyway, there we go. Let's put him down and screw our screw in. Put the second one in case they don't line up exactly. Still move it. There we go. Right. Now it's probably an overkill, a heatsink like that. This tray probably doesn't get very hot at all, but just in case it does, it's now fully protected, heatsinked. It doesn't need a fan. It certainly won't get that hot with that heatsink on there. But the transformer, we will be putting a fan in the box. Righto guys, now what I've found is an old power supply case. Double case. It already had an IEC connector in here, so we can use that. I'll be putting another outlet for the transformer, possibly a round XLR power connector. I'm not 100% sure on that yet. I might just run a lead out. Might run a lead out of this with a 3-pin socket on it. So that might be the go. This I'm using this one as the bottom. Now what I've done here, the heatsink's on him, as I showed you earlier. I've taken the LEDs off and the pots off. We've got to wire those separately on a flying lead. And the active lead I have soldered onto the main board. I don't trust the nuts and bolts, so I've just soldered them straight on. So he'll be going up in the corner like this. Now the power transformer, it needs a separate power transformer to run this, as it relies on the AC, which is 9 volts out of this little one. It relies on the 9-volt AC here for the switching of the MOSFET. Now, I don't know how this circuit works. I have no idea. All I know is you cannot feed a DC signal into one of these little boards. It has to be AC. What I've got here, fairly small transformer. He's, what's he rated at? 3 VA. So, we're looking at a couple of hundred milliamps, 500 milliamps. And the board itself, I have tested draws exactly, well, this one, 70 milliamps when it's operating. So this transformer, it's only a bubby, it's well within spec. I've pre-wired it because he's actually going to sit in there and he'll connect to the board and our IEC up the back. So that's sort of how things are going here. We may take this back a little bit away from things, but I don't want it too close to the power sockets at the back. All right, that's where we're up to at the moment. Hope this gives you some ideas on how to put things together. I've very randomly put things together. There's no method or anything in my madness. It's just find a case, tack things in, and see how it all works. With the LED display, we might actually we might be able to use this side instead of the IEC cable. We might just hardwire 2 cables on this and put our display in here and put our controls and our LEDs across the top. So there's an idea. All right, full of ideas. Don't know what's going to happen yet. I'll have to measure this up. All right, we'll get on with it. So what we're doing here, this is the top of the case that I have. There's the bottom of the case, this power supply case that I'm using for this. I'm just cutting out a cutout here for the little board that comes with it, the little display board for the time and the current. So yeah, just a little bit of filing out. I've cut it now, and so we can fit our numbers in there. This goes into the bottom of the casing, so everything's right. So we're just going to file a bit here. You'll see how it all works. Yours is probably different, but if you've got a plastic case or something like this, well, this may give you some ideas. Okay, so we can fit our little display in there. These can protrude further out. I'm going to put a little bit of a spacer behind it, so the whole thing is flush when it all goes together. And we can blanket off in the background there with a little bit of black elastic or something like that, or black tape, and yeah, just makes it nice and smooth. Now the other thing we've got to put in now is our LEDs. So I'm putting, how am I going to do this? Probably 1, 2, 3, and 4 across the top, so that you can easily see them for the trigger, the power, the time on, and power out, or whatever the other one is. Okay, so we'll do that now. Now for this project we need a foot switch. Now what I've got here, it's in pieces at the moment. I just bought this little fella on eBay. I think it was $8 or $10. One screw, you pull the pin out, comes apart, and inside you've got a little micro switch. We're going for the common and normally open, so that when you hit the switch it closes the contact. Now I found some old cable, using about 3 meters of cable. This cable is looks like old security cable or something like that. We're only using 2 wires. It's only low voltage to trigger the circuit board, trigger the electronics on the circuit board. So we'll strip this and solder him on here, put this back together and test him, and that way you can see, well, how to do a foot switch. You can use these for any particular purpose, really. So anything at all. Okay, we'll do that and come back. Now this cable, I've just found out, it must be old audio cable or something like that. It does have a shield and 3 wires. There's actually 4. I've cut the white off. I'm just going to use the outside shield and the green, tie them together, and the blue and red for the other connection. That way, yeah, we use the 4 wires in case one ever comes loose, breaks or whatever. Well, it relies on the other one. Okay, I've slipped a little bit of heat shrink over the end of him just to tidy him up. We'll use this one as this one. We'll go to our red and blue. Okay, and we'll put our ground one on there. Now just remember, if you're doing this and you're putting a plug on the other end, make sure that you feed it through a hole or whatever you're using before you solder the switch on. Righto, well there he is finished. Just a standard mono 6.3 mil jack plug, just a standard 6.3 jack plug. Let's check him. We've got him the multimeter on ohms. Just check him to make sure when after you've done him he's right. And there he is. Okay, so all we've got to do now is put the jack for this in our case. Well, guys, I'm just bringing you up to date on where I'm up to at the moment with our little box here for this spot welder. Now, got everything mounted in this old case. I have fused the input side of the 240. I like fuses. Yes, it's a 10 amp fuse in there, fairly hefty, but I wanted the transformer protected, protected in case our triac shorts out, something goes wrong, at least a fuse will blow. That's the original socket that goes in the end of this. This is the XLR type power outlet. Now our transformer plugs into that. That is the only socket that the transformer plugs into. You cannot plug it into a power point. So it's got to work through the switched part of this. I will also be having an override switch here where I can manually press a button and it will stay on for the button time, but mostly I'll be using this on automatic. I'll show you how to do that. This little fella, heat sinked, he was a little bit above the bottom of the case. I've put a little bit of rubber in there, double-sided tape, so that it doesn't bend and break the legs there for any reason. Our low voltage transformer, just a standard little everyday 9-volt AC transformer. So nothing special there. The trigger is a mono headphone jack, 6.3 mil jack, nothing special. It goes over to here and the transformer plugs into this one across to, down in there. This goes to your front panel, to your display, and these, which I will show you what I'm doing, these fellas are the LEDs. We've got to wire these to the other side of this yet, and these are the pots. I've removed the pots, as you saw. These go to the current and time pots. Now, the top, there we go. Actually, it goes that way up. That's your current set, that's your pots. I've mounted the LEDs in there accordingly. We'll put probably a little bit of labelling on there. This fella fitted in okay. Not very special in the background there. The LEDs that I've got to connect up and possibly put some sort of clamp on the wire to hold it in place. And the same with the display. The display plugs into that fella. Okay, so that's where I'm up to at the moment. Now I'm just up to the wiring stage. I'll give you a look at the wiring and when I'm finished. And now let's check out the transformer and see where I'm up to with it. Okay, well, here's our transformer. As you can see, power cord with our plug on him that plugs into the side of our control unit. I also have a fuse in this fella as well. I like fusing things. It's just an overkill, but on this, because it's already fused in the box, doesn't matter. I just fuse things. Cables, haven't done anything with yet. We've got to get our alligator type arrangements on the front here. Don't quite know what I'm going to do there. But anyway, I'll bring you up to date as soon as we start this. Okay, that's where we're up to. Okay, well, the next part of this spot welder thing, I've got to get this finished. This has been laying around for a while because I need the thing. So this is the bottom lead. Now, what I'm doing here is I've got some timber. I don't know what this is, 30 by 30 probably. 20 by 20, 22, something like that. And I'm going to set a piece to rest that one on at the bottom and make this so that I can screw this down. I'll show you this in a minute. I can actually bolt this fella down. Now, that will be bolted onto, as I said, I'll show you, a right angle piece that goes in here, possibly down to the bottom and up. And I'll show you why it's a right angle piece of metal. It's a little steel right angle. Okay, so up the top one, we're doing a similar thing. He's going to be mounted up here. He'll probably have the lead running underneath him. I don't know where this is going to go, and that will be spring loaded against the bottom one, and the jaws activate like so. This is very hard to explain. I know what it is in my head, but just yeah, this is only my design. You design yours however you would like. I would like these cables actually to come out at the side rather than in the middle, so I may rearrange that so we can put the yeah, it makes it easier to put these on. Now what I'm using is it's copper strip. It's out of an old rack system, out of a radio station. Now it's solid copper. I've got stacks of this stuff. So I'm just going to cut a piece like that. I'm going to put a couple of screws in it, a couple of holes, and screw onto the angle. And then I will also taper off onto a point at the end of it for the 2 points that go together. So yeah, it's pretty hard to explain. Just um, I'll guide you through, yeah, with what I'm doing, and you'll see the end result. That's the easiest. Your ideas probably totally different to this. This is just how I'm doing it because I've got heaps of this copper strip. Okay, a lot of people use rod, so yeah, round rod to do this. But seeing I got stacked to this, well, yeah, we can soon file it off or put it on the grinder and put it to a tip. And yeah, I've got endless tips in this stuff. Okay, so that's the next thing with that one. I've just got to work out how these things are going to work. Yeah, we sort of need this one of these on top up here on top of this piece that comes out. But anyway, okay, there's a bit of building going on here. Now, what I'm doing is I'm putting a couple of blocks on the end of where our transformer's mounted on the cabinet where it goes. Drilled a couple of holes, just ordinary timber, 30 by 30 I think. And these are going to go in like this. I must have drilled that right. I haven't actually tested it. I thought, geez, hope it's right for the camera. Okay, so we tighten. I'll just get the nut on this if I can. Yeah, no preparation with this video. She says you go. Okay, so I've got my 2 blocks of wood there. I've mounted one of the cables down the bottom. I've used an angle bracket. Now, I know this is not copper. My copper will be on here. It'll be bolted to the end of this. And yes, this is not copper. You're not going to lose much voltage or current between there and there. Very little. So, up the top here, what I've got is this fits in there'll be a rod running through here with some nylon washers, and it will operate sort of like that. I've got to round off the end of this and then drill our hole, put our, I'll probably use threaded rod right through there so that, yeah, that can move. And some sort of, I'll have double springs on this, some sort of dual springs either side to push this down against this. The top one will be virtually the same as the bottom one, and my two pointed copper strips will be bolted onto these. That way, if they wear out or whatever, I can just make more. You're not buying things. Okay, so that's where I'm up to at the moment. Hope that all makes sense. Yeah, this goes underneath the timber on this and will attach exactly the same way as this one, only up underneath the terminal. Well, not the terminal. Underneath this fella up the top. Okay, so that will be the action. Hopefully all this works. Everyone has a different idea of making these. But anyway, that's my idea. Hope you can take up something from it. Well, geez, I hope it works good. There's a bit of effort gone into this, and I've got piles of radios to do. Anyway, I need some of this for my radio chassis to make some dial lamp connectors and so forth. All right, we'll get on with this piece, and yeah, don't know what next. But anyway, it's happening. This is a very quick update. I've got to put some spring action in here somewhere, possibly up here, a couple of compression springs, possibly from down the bottom here to a rod or something on here that pushes them down. But anyway, that's what I need. And at the front, that's where my my copper strip is being mounted on each one of those, ground down to a point on each side. So it's starting to make sense. Okay, hope you're following along. It's a bit of a bit different to what other people have done. But there she is. And if you're making one, just remember, fuse it. Okay, you don't need a fire or something going wrong. Righto, we'll be back soon with the next update. And the next update. Okay, I've got this little roller. Now, I pinched this out of a Venetian blind mechanism up the top of the blind that actually rotates the blind, the string itself, the cable. Now, I'm only going to use one spring on this, and I'm going to push the leads to the side. I need a spring in around there, which is just the right amount of force. It'll be a little bit more with this. What I'm doing with this, I'm cutting this, a piece off this. That fits on there perfectly. So I'm going to cut this out. So we've got this piece on the top of this. Screw this down to here, and the spring will sit on top, and the same underneath. Okay, that's the theory. I'll go and cut this and come back to you. Well, I'm back, and yeah, that didn't work as expected. Next idea. Okay, I want that spring to go in around about there. It's got to be a little bit higher. So what I'm going to do is I'm going to put a screw down through here so it goes into the spring, and a small bolt, and holds the spring as it is on the top. The bottom, I'm going to put a length, either a bolt or a bit of threaded rod, probably a threaded rod, up to about half, so the spring doesn't bend when you're pushing it. and that the spring will sit on the bolt or the rod, and try and get this over just enough there, just a screw or something like that, even a tech screw into there, so that this sits in the top of the tech screw. But this will be held, and that way I can also put another nut underneath this to give this more height and adjustable as far as the leverage down. So yeah, okay. Next idea. Now the mechanism looks a bit wild, looks a bit more aggressive. Okay, put a bolt in here, washer, another bolt up on here, and we'll get all this working properly in a minute. And that is pretty well perfect for what I want it to do. Okay, so that's pretty damn fine. Now what I want to do is put some conduit or maybe some heat shrink over this to stop this making lots of noise, and the same up on here. I'm not happy with that nut. I wish the nut went inside the spring. But anyway, a washer will cure that. A nylon washer up there that it sits on. And I'll do the same here. I'll put a bit of heat shrink on it just to stop there's a bit of play there. That really doesn't matter as long as she does the job. All right, I'll get some heat shrink. Okay, we've got a nylon washer on there and a nylon washer on the bottom. Now, let's see here. Let's see the spring action, see if it's going to work. That is superb. That's good enough for me. Now, I'd like to put a little knob or a handle or something. I'm thinking maybe a knob off an old cupboard door. Sit it on there. Oh, just to pretty it up. Now, that's up fairly high. I don't know whether that's too high or... I don't think so. I don't want these touching. The pieces, the copper strips will come up a little bit above this, so there won't be much gap between them by the time it's all done. All right, well, that's good enough so far. Yeah, okay. I just couldn't resist myself. I had to get this knob on there. I reckon that's class all over, that is. Makes it look so professional and homemade all at the same time. All right, the next piece is our little copper strips, and I'll take you through when I'm doing that. Okay, but I'm happy with this so far. Almost looks like a big stapler, doesn't it? Okay. Now it's all starting to come together, and you may understand a little bit more about what I've been trying to explain. There's my copper strips, bolted on, and they look like that. I grind them down, okay, and there's a actual little flat on the end. Now this is only done by file. There's nothing special about it, and well, we'll put him, I think this fella goes at the back actually to line up with the bottom one. So nothing really special. That's what I start with. Cut off some copper strip and drill some holes. file it down. Well, not file it, but actually cut it on the grinder. But you can cut it with a hacksaw or grinder or whatever you've got. And just make sure there's a bit of surface area flat on top. You can grind these down almost to a point so you can do more fine stuff. I've got these so I can put a bigger point or a very fine point, and I just change these to suit the needs. I don't know whether all this is going to work, but that's the theory behind the whole thing. Now, putting this together, I pretty sure that's the way it goes, because my holes are almost line up, because I'm a technician, not a metal worker. So drilling holes in a line perfectly, yeah, not my forte, but this will hold it. Now I'm just using 6mm screws, ordinary 6mm screws with star washer so they don't come loose, and a little 6mm nut. Now all this is out of old radio gear, actually, old racks. So that's, yeah, just I'm trying to use junk material in this to show you how you can build things out of junk. Okay, we'll tighten this up. Now that meets there perfectly. That's all I need. Yeah, these aren't quite straight, but this is. Okay, guys, I think we're ready for a test, eh? I'll get the other half of this, the bit that this plugs into, which is our timer board, timer arrangement. We'll plug it in and let's give this a go and see if it actually does anything. Theoretically, that probably should work, but, let's try it. Oh, love the knob. Okay. Okay, doke. We'll do all this in real time. Power cord. And our transformer plugs in there. As you've seen the build on this anyway, if you haven't, yeah, go. Well, I think it's at the start of the video. I don't think it's a separate video. Okay, let's plug it in. And she's on. Okay, do we need less light on this? So we can sort of see what's going on. Now, this is time. As I said, I don't know whether this is milliseconds. That's probably 500 milliseconds, I would say. And that goes down to 1. Okay, we'll put it up to 10, which I think would be 1/10 of a second. Our current, we'll leave it low at the moment to see if this is going to work. And you might even see smoke if it doesn't. Okay, there's our foot switch. Put him down here. Obviously, I can't show you the foot switch on the floor. He plugs into there. And if I touch this, and I'm guessing transformer is working. If we up the current there, yep, I heard it. There you go. Not much to hear, but okay. So currents there, time. Okay, let's get a couple of little pieces of something and see if this works. Okay, I've got some material. I've cut up an old jam tin. Well, had to eat the jam first to get the tin. flatten him out, and we're just going to see how we go here. We're going to tack one onto the other and start off at a low setting and work our way up. Now, this tin at the moment it's not very thick. Okay, let's have a bit of a look. I'd say, yeah, 0.3 mil. Okay, so it's very light tin, actually 0.2. So there's a lot of jobs that this is lined up for if it works. My wife does a little bit of garden art work, small things, garden art things, and having something that can weld small pieces together without it being a welder or brazing or soldering or anything would be really handy. And me, of course, well, radio chassis and so forth. Okay, so if we put that there, okay, so we should be pretty well spot on. Hit the foot, and not much happens there. Okay, we got a little bit of current, we got heat there, but a little bit of current, but not much. Okay, so let's get some more current happening here. We'll go up to say 40 and try that. And have we got anything there? Yes, we've got a burn almost through. So okay, well that's a start. And this is me doing my testing. Okay, let's go halfway. Let's go up to say 60 on there. And that was a bit, and as you see, it has gone through, and yeah, pretty good actually. Did break, but that's good. All right, let's try this again. Let's increase it 3/4 of the way up. Well, say 80, and let's hit that. And that certainly went right through. No worries there. All right, that's quite good actually for something that size. Very, very handy. Okay, let's go full power. Now we haven't got the time set yet. We're still back on, what is it, 110 milliseconds, I guess. So full power, because this is only fairly light. We'll try that again. And yeah, a very good weld. Went right through, no problem. And yeah, you wouldn't get, I'm not going to cut my hands here, but yeah, that works fairly well. Okay, we'll try on the other side. We'll increase the time up to 260 milliseconds at full power, and we should almost get a burn through of this. So we'll just see how this goes. And yeah, no worries at all. Straight through. Yeah, very good. We'll get another couple of pieces. Righto, guys. That's not bad welding. That will do me anyway for the use. We'll get something a little bit heavier, and we'll see what we can, attach to this onto something a bit heavier. And I've got a heavier piece of metal here, which is, how thick is it? Okay. What have we got here? 1.5 mil, 1.44. Okay, so I want to attach that bit of lighter tin onto this. Let's see, can we do this? And see if this works. Sure can. Went straight through. Alright guys, we'll try that. Went right through. No problems. We take him down here. Let's put him on there. And look at that. Spot welded. No problems. That suits me as far as doing stuff with radio gear. This is really, really a good thing. And that's very hot. These fellas, also very hot. A lot of current happening there. As we measured, about 1200 amps or whatever it is at 3 volts. All right, guys, I think this is a wrap. I think we've done it. That is our homemade, whatever you'd call it, spot welder. Now I'm going to have to name this thing. So stand by. Right, guys, there he is, Alligator. Okay, so that's his official name, Alligator, and he works like a dream. Now, another thing that I have bought from eBay was the little machine to do 18650 battery tags. All I've got to do here is put some wires, well, a couple of heavy duty cables, but flexible, and attach them to here. And then we can use this machine to run this little device. This can also, I'll put a plug on it and be used into the foot switch of the little control unit. So yeah, these are only, I don't know, $15, $20, whatever they are. Okay, so when you push this onto the 18650 tags, they're nice and small, the actual lugs on it. Yeah, everything should go okay with this. But as I said, it's only a matter of paralleling with these. That's there's a couple of, actually I'll be leaving this screw and this one a little bit longer so that we can just use a, I don't know, an eye terminal or something like that to go over and put another nut on him. And then we can just use this as it is with this. All right, so that's it, guys. There's Alligator. Thank you very much for watching. I hope it's inspired you or given you some ideas. Certainly it will be used a lot at this end. It's not a super machine, but cheap, very, very cheap. Okay, which to me is all part of it. And custom built, all part of it. Build it yourself. It's fun. But with those high voltage transformers, you've got 240 going in, just as I've said, just be careful. Okay, guys, that's a wrap. We'll catch us on the next one. Have fun building one of these. Yeah, you'll probably have lots of fun building little projects with it. Okay, until next time, bye for now. By the way, guys, we tried some of this 1.5 metal on this, 1.5 to 1.5. Does it easy. So there we go. It'll probably do 2 mil, maybe, but works well. Very happy. Bye.